Okay, question number 28 has a little slight hiccup here because we have an a value that is a fraction. Let's go through this together, class. It's asking us to convert this to vertex form, which means we're going to have to complete the square. So let's go ahead and do this. I do not want to deal with this a value being 1/2. I've got to factor that out. So 1/2 times x squared gets me back to 1/2 x squared. And 1/2 times negative 8x. This will throw you guys sometimes. 1/2 times 8 is 4. So 1/2 times negative 8 is negative 4. And then we have to actually put this plus here. So just class, take a look at this. You got to realize when you put the 1/2 out front, when you factor it out of these first two terms, you better figure out when you redistribute this 1/2 into these two terms, you come back exactly where you started from. So now we can go ahead and draw our area model. My drawings are not very pretty, but they don't have to be pretty. Here we go. Here's our x squared. Negative 8x divided by 2 is negative 4x. This is negative 4x. That means our dimensions, not hard at all, our dimensions are x times x is x squared. X times negative 4 is negative 4x. X times negative 4 is negative 4x. So class, if I was doing this problem, the moment I factored out the 1/2, I would have put that right here so I don't forget. Then I will leave a blank for the H effect and a blank for the K effect. So now we got our 1/2 there. Now the question is, what number do we have to add to make this a perfect square? The answer is easy. It is negative 4 times negative 4, which is 16. Take a look at this, class. We had this -1 hanging out over here, and I'm going to stick it over here at the end. The question is, how did we now modify our equation? All the light blue is exactly the way our equation began. What did we do to modify it? Well, we added 16 here, but you don't want to subtract 16 because we didn't add 16. We added 1/2 times 16. So half of 16 is 8. I'm going to write it like this so you see this, class, minus, I'll do this in red so you see where this 16 is showing up over here. We're taking this and we're saying we added 1/2 of 16. We're going to subtract 1/2 of 16, which is -1 minus 8, which is equal to -9. And there is our -9 right there. And then the number inside of the parentheses, class, we see it right here in our perfect square. This is x minus 4 times x minus 4. There is our equation. As usual, I'll go ahead and say, well, this tells me h, k, and a. Our h value is the opposite of the one you see in parentheses. That's positive 4. Our k value is -9. And our a value is 1/2 in class. I'm going to convert that to a decimal. To me, it's just a little bit easier to work with a decimal. So I'll just change it to a decimal value. 1/2 equals 0.5. All right, here's our vertex. Our vertex is at HK, which is 4, -9. Let's go ahead and plot that. 1, 2, 3, 4, and -9 is right there. And now, class, let's take a look at the effect of 0.5 on our parabola shape. We know it's going to open up because the a value is positive. Here comes our normal pattern. And I'll just do 2 points on either side. We typically go 1 over and 1 up, and now we're going to go 1 times a. We typically go 2 over and 4 up. We're going to go 4 times a. So let's take a look at this. From our vertex, 1 over, 1 times a is 1/2. 1 times 1/2 is 1/2. There we go. We went up 1/2. Go back to our vertex, 2 over, 1, 2. 4 times 0.5 is 2. 1, 2. Look at how flatter that parabola is because the a value is less than 1. Let's go ahead and draw our line of symmetry right through our vertex. And let's go ahead and plot the other side. So this is halfway up, 1 over, so 1 over to the left. This is 2 over to the right, so 2 over to the left in class. If for some reason you just want to practice this, let's do the 3 over. We have room for it. So 3 over, we want to go 9 up with our parent function, but it's going to be 9 times a. So we're actually going to go over 1, 2, 3, and 9 times 0.5 is 4.5. 1, 2, 3, 4.5. And then let's go ahead and reflect that. 1, 2, 3. So 1, 2, 3. There we go. Connect your parabola together, add arrows to the ends, and you've got your graph finished.